Hello viewers, welcome to the channel. In this episode, we want to have a little discussion into main friction one, which is the length of a chord. We know a chord is just a line that connects 2 points on the circumference of a circle. So if I have this as a circle and I have a point A and a point B, any line that connects these 2 points becomes a chord. So how do we find the length of this in terms of calculation? We know one way we can do that is connecting the center. We know the center, a line from the center to any part of the circumference give us radius. So this is a radius, this is also a radius. Now, if you look at the length of the chord, the radius and the radius, these two produces what they call the isosceles triangle, because the length of this will be the same as the length of this. Now, from the circle geometry, which is the circle theorem, any line from the center towards the a chord is perpendicular. So if I draw this line is perpendicular to the chord. So in this case, if I have here to be A and B, you can see I'm having two right angle triangles which are going to be similar because the length here, which is the hypotenuse, is going to be radius, the same as the hypotenuse of the second triangle. Then the line from the center towards the chord divides the chord into two equal parts. So the value of this, if it is x and y, the x and y will also be the same. Since this line is also perpendicular, it will also divide the angle at the center into two equal parts. I believe you are getting it. Let's make it a little bit bigger so we can see the writing clearly. No, this is supposed to be theta, the angle subtended by the chord at the center. That's the angle here. So if I draw a line through, that line is perpendicular to the center. The angle in there, theta, will be divided by 2 in order to give us equal angles. Then this being the radius, if the distance from the center, which is the O, to this, let's label that D, and label here A and B. So this produces two similar triangles. So if I want to find the length of this, I can also say that the length of A is the same as the length of B. So if I find the length of A or B multiplied by 2, I get the full length of the chord. We are using A, B. Alright, so let's take it step by step. The first triangle, which is the first one here, let's try to find the length of A. If you want to find the length of A with the known trig functions that we have. If I take this diagram from what we are having, this is going to be A, this is going to be D, and this is going to be R. Then theta over 2 become the angle, right? So if I am going to concentrate on this, making use of radius as the known part, it means this is going to be opposite, then this is going to be hypotenuse, right? From the trig functions. So I'll be having the sine of the angle. The sine of the angle equals to the opposite side, which is A, over the hypotenuse, which will be R. Will we get it? Good. So now I want the A, which is the side I'm looking for. So I am going to multiply both sides of the equation by the R. That gives rise to R sine theta over 2 equals to A. So now the length of AB, which is the chord, is going to be 2 times A, right? 2 times A, because the A is the same as what? The B. So if this is 4, 4 plus 4 give us the same value. So A times 2. And what is the A? A is R sine theta over 2. Therefore, our length of our AB is going to be 2 times R sine theta over 2. So this formula can be used directly to find the length of a chord, provided the angle at the center is known. If the angle subtended by the chord at the center is known, then we just go straight forward without going through all this stress we are doing. Because whatever we are going to do using the trig functions will result into this. So if I have any question that make use of the angle, then straightforward I am going to use this. So let's see, for example. So if we have a question like this, we have to find the length of a chord of a circle of radius 7 centimeter which subtend an angle of 70 degrees at the center. So here we are looking for the length of the chord. This angle at the center is provided. So straightforward, we are only going to do a substitution to our formula. The length of chord is going to be 2r sine theta over 2, where we have r equals to 7 centimeter, theta equals to 70 degrees. So direct substitution will leave us with 2 times r, which will be 7, times the sine of 70 over 2, which will be 35 degrees. So if we put this in our calculator, meaning 14 times sine 35, that gives us 8.03007. So to the nearest whole number, we can get x centimeter as the length of the chord. So we can see it is easy if we just have this formula. Now, there are times whereby the angle at the center is not known. So how will we be able to find the length of the chord? So in the same vein, if the angle at the center is not known, then it means we are making use of the x plus x being the chord, then the length here. This is going to be the distance. The distance from the center to the chord will be provided. The moment that is provided, then it means that we are going to use the Pythagoras theorem, which says that r squared equals to the sum of the two shorter sides, x squared plus d squared. But don't forget, we are paying attention to the x, which is part of the chord. So that means making this the subject, r squared minus d squared will be equals to x squared. Let's make x to be the subject alone by finding the square root of both sides, meaning x will be equals to the root of r squared minus d squared. But are we looking for x as a value? No. We are looking for the length of the chord from A to B, x plus x, which are the same. So if I know the value of x, then it means the length of chord is going to be 2 times the value of x. And what is the value of x? The root of r squared minus d squared. So per generalization of a formula, we can also say that the length of any chord where the distance from the center to the chord is known, we use 2 times the root of r squared minus d. So if you substitute the values into that, then voila, you have gotten the value of the length of the chord. Okay, so look at this question. What is the length of a chord which is at a distance of 6 centimeters from the center? A distance of 6 centimeters from the center. of a circle of a radius 8 centimeters. So we can draw the diagram as in the case of this. We can make a sketch of that diagram. Then we have the distance from the center to be 6 centimeters, the radius to be 8 centimeters. So per the use of Pythagoras theorems, we can be able to find this and we multiply by 2. Or we only say that the length of chord equals to 2 times r squared minus d squared. I believe you can remember the formula, how we arrive at that. So with this, we only do our substitution of r, which in this case will be 8 squared, d, which in this case will be 6 squared. So 64 minus 36. So 2 times 64 minus 36 will give us 28. Then we can have 2 times the root of 28, and that will be 10.58 centimeters. That is to 2 decimal places. So you can see that finding the length of a chord when the center is given, we follow the first formula. When the distance from the center to the chord is given without the angle, we follow this. Any of them can be given, provided the conditions are met. So like if you follow this, share, comment, and subscribe. Bye-bye.